Hello and welcome back to compiler programming. Today I want to work a bit on the if instruction or if statement. And in particular, if we try to go into the disassembly of this code, we will see that currently our if instruction handling is not very nice. So like all of this code, I believe, and maybe even this stuff. Yeah, I think all of this is actually just what goes inside of an if. So that's quite a bulk of code. I don't particularly care about its performance, but I care that it's hard to read. Same as with other optimizations that we have done. And there is definitely something to be done here. I think there are like if you compare against 0, then you could probably use test instruction, but hopefully we can make this whole thing disappear entirely. So that is that's something to consider. But what I want to do more is to get rid of this stuff and try to change two compares into one compare somehow. Now, this will probably require us to make the Eflags register to be something explicit. So I think we are gonna start with that. And this is our instruction file. So we have registers here, and I'm also gonna do like Eflags, operand size. That's a very good question. What is the operand size of it? I guess because we can only do set E and set B and whatever, then we say that operand size is 8, although it's a bit awkward because this register doesn't really have size in traditional sense. But here we say Eflags. Okay, we also need value.h, where we will need to add this special operand type. So operand type Eflags. And we also want the encoding type to be as well. Instruction encoding type Eflags. Let's try to build and see where we need to end them. So first is here, and I guess if we get to Eflags, then we just say true. And here, it's also pretty straightforward. Eflags. Cool. That should not change anything, but doesn't hurt to run the tests just to see that everything is fine. Now we are ready to start changing things though. So there is this enumerate cc helper macro that basically is there to create jump equals, jump not equals, and so on and so forth. So it takes this suffix and adds extra opcode number and produces all the different mnemonics, and then there is a corresponding setcc, which is sets a byte based on the flags. Okay, so we have one operand. What is encoding take again? It takes an opcode and okay. So I guess we should be able to just say now Eflags and Eflags and Eflags over here. Should also undefine it to not pollute the global namespace. Now everything should still build. However, if we try to run it, we should get basically complaining that it could not find instruction encoding. I believe that's what's going to happen. Yep, so now it does not know what to do with set L. And we can go to let's make if, I guess, and look at this stuff. So we are matching on if, we are doing this, and then we're calling make if. So for that we need to go to the function .c and look at what make if does. Okay, let's look at this stuff. So right now, so there are sort of a couple of issues here. The first one is that inside values, Eflags should actually carry not just the... So let me explain the issue. So we have if, for example, x more than 12, right? What it expands to is we do a compare, and then we use a combination of flags inside of Eflags to change the type of jump that we are making. So here we are comparing a value with 0. So this is a case of like this, just if x, right? We are comparing value with 0, and then if it is equal, so this is actually, I think better mnemonic here is jump equal. So if it is equal to 0, then we jump over the content. So this is how currently if works. And if we have something like this, then what happens is we do another compare, and then we store the result of that compare inside of a byte, and then we end up in this branch where we compare that byte with the 0 and going from there. This is exactly what we saw in the disassembly of the output. And what I want to do is that this operation sort of leaves its result in a special form that would allow if to then consume it without this extra machinery over here. And this is what I'm trying to figure out, what is a good way to go about that. I guess what we could do is we could start with an easier one, and I'll go back here and I will only add it to the setcc variant and fix that first. because that should be more straightforward. Function. What do I want? I want compare. This is what I want. Yeah, so these are all of our different comparisons for stuff, and this is where we deal with set E, set Z, and so on and so forth. So we compare, and then yeah, the idea would be to move this set Z, set E, and so on to the MoveValue code instead of it staying here. So here we have compare, right? But as the result, we will return a special value that will be that Eflags. So actually we'll need to change slightly this stuff and have extra information. So operand type. Okay, operand, here you are. How do I do that? I guess we have this compare type, and I can use it inside of that value as well. So let's open up here. I assume they define here. Yeah. So I'll take this stuff, we'll move it to the value now because it will be part of this thing. And we will eventually expand this to handle unsigned numbers, but for now we don't have them, so that's fine. Just put here compare type, and then we had operand equal, right? Where we need to fix this and say that return a compare type is b compare type. Okay. And another thing that we want to do is to have something like this. This is just a helper macro that creates a value with source location, so it is easier to track it. So we would say a value from compare maybe, and we pass location, we pass program. Do we need the program actually? No, we do not. We just need to have compare type here. Compare type. Descriptor of this value is going to be quite funky as well, so we might need to introduce explicit like, I guess for now I can pretend it is a byte, although that's not exactly correct, but for now I guess that will work. To do consider adding explicit boolean type. So here operand type Eflags, and then we just say compare type is compare type. Okay. This is, believe, compare complaining to us that we did not do the right thing. Yeah. So now I can say value from, how did I call it again? Value from compare. I guess I'll need to include it in the header, but it's fine. I just need to do it like so. Yep. And I just pass the operation. That sounds good. And we can return it maybe. Okay. Looks like my jumping to the location is a bit broken, but it's fine. I can fix it differently. So that was here. Yes, we need to do it that way after all. Must return a value. Sure. Okay. So that is that. And now, oh, I forgot to set the byte size. Byte size is 1. Okay. So these things now should move to the move value. Move value. I guess it's somewhere here. Yeah, this is the most complicated function in our code, and maybe at some point I will want to make it nicer. But for now, this is what it's going to do. So if source descriptor type is descriptor type Eflags, so we don't need result, right? We just need to change on source descriptor. Sorry, that's actually not descriptor, that's operand. Operand type Eflags. So operand compare type. And now we switch on that. So right now I will try to just do this and say assert I guess I have to deal with it right away. So the problem is it can only set a byte, right? So if on the left side we have something that is not a byte, then we would have issues. Okay, let's try to not do anything with that and see how that will work out. Push instruction. Yeah, let's see what's gonna happen. I'm not exactly sure how we are using this. Also, I'm not sure that we have this thing for any that basically copies any operand into itself if it is passed as a target. And I'm not sure if this handling needs to happen before that or after that. So here set z, and we need to go into value h, and we have, where do we have all the register stuff? Register, register, register. So I guess we can do source operand. Okay. That is a lot of issues. What did I do that made it so upset? This works, but suddenly this doesn't. So what's wrong with the switch statement? Ah, yeah. It's just my error highlighting is broken. Need to fix it. So it's like this. Cannot convert from value. Okay. Target brand. Operand. Okay, great. Well, let's see if that is better. I'm just thinking if we need to change anything inside of encoding, and we actually do. So the list that we need to change is this matcher. If operand type is operand type Eflags, and encoding Eflags. Something like that. Okay, let's try to run the test and see what happens. Okay. I kind of have an idea what happens actually, and in a sense it's good that it happens that way. It might cause issues later, but for now we actually maybe are happy that this is how it goes. So what is happening here is, as you can see, there is nice sort of a compiler stack trace that tells you that this instruction was added on line whatever function C. This is 430, so this one, right? And we had a compare, and this operand is now Eflags. And so we need to, oh, I'm not sure I like how this is always true handled. Unique label, I guess it always wants to have a label back. Okay, whatever. Here we need to handle the Eflags. So if we say now that if value operand type is operand type Eflags, so if it's not, then we do the old thing, right? Because we still want so stuff like this work, right? We want to be able to, or more precisely stuff like this, right? This still should work. But here we can do something better. And in particular, we could copy this stuff. Maybe there is another way to dispatch this, but for now that works. There is no particular problem with that. And unlike set, we sort of need to inverse the conditions, right? Because inside if we jump if it doesn't match, because we jump over the instructions that are necessary. So here would be JNE, jump not equals. Here is jump equals. Here is jump greater equals. This is jump greater. This is jump less equals, and this is jump less. Right, so I'm just taking this stuff. So for example, if I have this, then reverse would be this, and with vice versa, right? And we have this and reverse this. So this is the only thing I'm kind of did the mapping here. Okay, and now I'm just considering if it would make sense to match on the compare type somehow inside the operand as well and do the dispatch in the encoder, but it's fine. It's fine as it is. So value star Eflags is value from compare, and we have instructions, and we have compare type equal here. Not that it really matters what we put in there. This is kind of annoying that we don't have now error highlighting, but I know what's wrong. We have value operand, and that's it. So it's like this, I guess. Label, 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 label. Okay, much better. Cannot convert value star to operand type. not convert array instruction star to compare type. Actually, this is just like this. Okay. And going into the instructions, now I do need to put this stuff over to here. Okay. Not actually certain that we really need to have it explicitly here, but I guess it doesn't hurt that much. Well, let's try to run tests and see how we are doing. Okay, set z r32 Eflags. I guess let's run it in the debugger and see which code actually wants to do that. Or to do that, basically we need to go to MoveValue. Let's just support this. How would that work? Value star temp is operand byte size of source operand. Is 1, then target. Otherwise, we need a temp thing, so we would get value register for descriptor, and we say register A, and descriptor is 8. And then we put it to here. And here we say if temp is not target, and then we just recursively sort of call ourselves and move it there. Now there is obviously a problem that if target register is actually register A, then we are kind of screwed, but we use it in a lot of places anyway, so you know. And this is I think the time to get our at least basic register allocator is coming in rapidly, but it's fine, we can deal with that as well. So instructions, location, and then target temp. I guess it's and descriptor byte size of target. Those types from value star to descriptor, target descriptor. Okay, well, let's try again. And here we go. Everything is amazing. We even have our fizzbuzz working. But let's get back to the original thing and look at how much better, hopefully, our code actually looks like. So back to the assembly. jump inside, jump till here. And if you remember, we had two comparisons in here, and now we just compare one. So we basically, this is still not optimal, but it is definitely something that is much, much better. So this is actually something that can be pretty easily optimized by adding more cases and checks to MoveValue. But what I wanted to do for today and what is done is this part. So now we actually do only one comparison instead of two, and we use the right jump here, which is very, very neat. And here we see the set E. So in some cases we sort of still do the old version of it, and we can maybe look in FizzBuzz as to try to figure out why that happens. We might not be able to do it at the same time. Okay, let's just open it here. So anyway, the main part is definitely working, which makes me very, very happy. And there is still probably stuff to clean up here. I'm not exactly certain what code is this one. So this comes after the division. Div. Okay, it looks like it is this code that is causing the wrong thing to happen, but actually that is because it is actually what we are doing, right? It's not that our code is stupid, it is literally we are comparing it to 0. So there are more efficient ways to compare to 0. So like you could you can do the compare and then inverse the condition, but as far as the code goes, this seems pretty fine to me. So this is okay. Cool. That would be all for today. Thank you very much for watching, and hopefully see you next time.